Okay, we're about to get started on lesson 22, finding measures of angles formed by transversals intersecting parallel lines. So, making sure we're all set up on the technical end, go ahead and start posting your questions you have in the comment or message box below, and I'll be able to take care of those during the live stream. Also going to get the behind the scenes camera set up that will broadcast to the Facebook page of Florida Math Exam. And as always, you can get to the area that we're broadcasting by going to floridamathlive.com. Okay, let's see if we can get the behind the scenes camera working here. Okay, hello and good evening. Welcome to lesson 22. We're working on finding measures of angles formed by transversals intersecting parallel lines. And remember to post your questions. If you have them in the comments, I'm just going to put them here. Okay, there we go. All right, let's get underway. Everyone's settled. Go ahead and take pictures of any questions you may have if you're doing summer school or working through any course of your own. Just take a picture of it or put it in the comments, and I'll be able to answer that during tonight's live stream. Okay. Also, remember to go to floridamathlive.com if you'd like to see what we're writing here. Okay. But go ahead and put any questions you have, or if you get lost into the comment box, and we're going to get started in just a moment here. All right, here we go. So finding measures of angles formed by transversals intersecting parallel lines. So the parallel lines they're talking about in this case are the J and the K. So these pens would be forming parallel lines, and a transversal would be a line intersecting both, like so. Okay, so again, in the description here, so the figure below shows two parallel lines, J and K. The parallel lines are intersected by a transversal T. A line that intersects two or more lines is a transversal. So there's special pairs of angles that are formed when a transversal intersects two lines. All right, so there's a few different definitions here. We have corresponding angles, and those are angles that are on the same side of a transversal and on the same side of the parallel lines. So with that definition that we have there, I'll zoom in a little bit and see if you can identify on your own corresponding angles. See if you can pick a few corresponding angles. So corresponding angles are on the same side of a transversal. So it might be easiest to think about covering up one of these sides. So remember, T is the transversal, and corresponding angles would be perhaps, looking at this, if they're on the same side, they're going to be the same measure. Okay, so we could have 2 and 6 would be a pair of corresponding angles. Also 7 and 3. On this side over here, we would have 1 and 5, and also 8 and 4 are our pairs of corresponding angles. The next thing we talk about is alternate exterior angles. So alternate exterior angles are on the outside of the parallel lines and on the opposite sides of the transversal. Alternate exterior angles have the same measure. So the example here talks about angle 2 is above line J, right? Here's angle 2. And angle 8 is below line K. They're opposite sides of the transversal. So we're on the right side of the T transversal 2. And if we go on the outside of the parallel lines and go to the other side of our transversal, we will see angle 8. And angle 2 and angle 8 will have the same measure. What is another pair of alternate exterior angles? So we have 1, and then if we go to the outside of the parallel lines and to the other side of the transversal, we have angle 7. So 1 and 7 are alternate exterior angles, and they have the same measure. We just covered alternate exterior angles, and of course we also have alternate interior angles. I bet you could probably figure it out from the definition, maybe a little bit self-explanatory. So alternate interior angles are on the inside of parallel lines and on opposite sides of the transversal. So we lost our graphic. We just say we make one real quick. Almost parallel, right? Okay. So alternate interior angles. One of these alternate interior angles. So we're looking on the inside here. So this would be, let's say we're going to look at this angle. And if we go to the other side of the transversal and stay inside of the parallel lines, this would be its buddy. These two are alternate interior angles. And notice I'm using this single arc to show, that's how we would show that those have the same measure. We could also say, using a double arc, that this interior angle has a buddy over here. This is the other alternate interior angle, and those have the same measure. Okay? Good deal. What else do we have? We also have vertical angles. Let's draw another example of vertical angles. So vertical angles are opposite angles formed by two intersecting lines, and vertical angles have the same measure. So let's do our parallel lines, or at least close to parallel, right? And there's our transversal. Let's identify one of our angles. Let's say we're talking about this angle. So where is, if we're talking about vertical angles, what is this angle's buddy? What is the vertical angle from this angle? So that's going to be actually sharing the same intersection, but opposite, okay? So not next to, but opposite. Another example would be like this one. And this one's buddy would be on the opposite side of that intersection over here. Fair enough. Okay. How about same side interior angles? So same side interior angles are between parallel lines and on the same side of the transversal. So same side interior angles are supplementary angles. A measure of supplementary angles add up to 180. Okay, so looking back at the example, okay, so what would be the same side interior angles? So if they're on the interior, we're looking at 3 and 6. They're between the lines and to the right of the transversals. Let's find 3 and 6 over here. So 3 and 6 on the inside of the parallel lines, and they're on the same side of the transversal. So 3 and 6 are one set, and 4 and 5 are the other set of same side interior angles. Okay, so let's see if we can start to figure these out. So we want to find corresponding angles and we want to find alternate exterior angles. And vertical angles. And alternate interior angles. And what else? And same side interior angles. And we can make a table, separate these just a little bit. Try to get them all to fit on the same screen and the same page. Okay, so corresponding angles. So what pairs could we be talking about? So corresponding angles, if you recall, those are going to be on the same side of the transversal, and they're going to be of the same measure, okay? So we have 8 and 3. We also have 6 and 1. Angle 6 and angle 1. We also have, what else we have? 7 and 4, angle 7 and angle 4. Also 5 and 2 are our corresponding angles. How about alternate exterior angles? So if we were looking at 1, where would this angle's buddy be? For alternate exterior angles, so these are angles that are on the outside of the parallel lines, and they're going to be on opposite sides of the transversal. So angle 1 would have a buddy with angle 7. We also have angle 2 with angle 8. Okay, and there's only those two sets because we're only talking about alternate exterior angles. We're going to have 2 more when we talk about the alternate interior angles, but let's finish the vertical angles first. So who would be a vertical angle with 7? Well, that would be 6. So angle 7 and angle 6. Also angle 8 and angle 5. Angle 4 and angle 1. And also angle 3 and angle 2. Those would be our vertical angles. Okay, how about alternate interior angles? So those are similar to what we looked at before, but now 3, if we're looking on the inside, 3 is one of our angles on the inside, and the other alternate side, so 3 is going to find a buddy with 5. The other set of alternate interior angles is going to be 4 and 6. And those would be it. That's all of our alternate interior angles. So how about same side interior angles? What is the clue for same side interior angles? Well, they're going to be in the same side of the transversal, and they're going to be inside of the parallel line. So 6 and 3 would be one set. And also angle 4 and angle 5 for the same side interior angles. All right. That was a good practice. I'll run down on finding all of our pairs and all the definitions that we just worked on. So here's a good example. So now we're going to apply what we learned via the definitions and how they work together. So we need to find all of these unknown angles. So this particular one is 50. This one over here is 40. And what do you think? Can we fill in all 12 of these missing angles with that's all that we have? Well, let's give it a shot. So vertical angles are equal to each other. So we know angle 50 here and angle 3 are going to be the same. So let's put a 50 here. Okay, what else could we work on? What else could we find? We have angle 40 and angle 8. Those are vertical, so those are both 40 degrees. What else can we do? Working on the 40, alternate interior angles are going to be the same measure. So 8 and 5 are the same, so this is also 40. We could use the same thing with the 50 alternate interior angles. So 3 and 7 are the same, so this is 50. We will zoom in a little bit too. Now, 7 and 10, again, are vertical angles, so this would be 50 as well. Okay. Where else can we go? So we can, these are on the same side. This forms a straight line. Angle 10 plus 11 forms a straight line. So a straight line is 180 degrees. So if we do 180 minus 50, we get 130. So this would be 130. And that would make 6 also 130 because they are vertical angles. What else can we do? Same type of thing over here. Angle 12 and this 40-degree angle will add up to 180. So 180 minus 40 is 140. So that's going to be 140 here. And by vertical angles, this one up here is also 140. What else do we have? So how about up here? 5 and 1 are vertical angles. So 1 is also going to be 40 degrees. And we can find 2 by doing 180, okay, because this is a straight line here. So 180 minus 40 minus 50 should give us 90 degrees. So this is going to be 90. And by vertical angles, this is also 90. Okay, so did we get them all? I think we did. So a few of them we used by looking at alternate interior angles, alternate exterior angles. Did we use that one? We did vertical angles. We looked at supplementary angles. Okay, where a straight line forms a 180-degree angle. So I'll leave this example up for just a moment so you can look at that. Let us know if you have any questions there. Okay, let's move on to the next one. Remember to post any questions you have in the feed, or you can message me and get you caught up. Okay. So this looks like a good problem to work through. It has several parts. So this first one, all of these questions deal with this figure. So how many pairs of vertical angles are shown? How many pairs of vertical angles? So remember, vertical angles would be like angle 2 and angle 4, angle 1 and angle 3, angle 5 and angle 7 are vertical angles. finally angle 6 and angle 8. Did we get them all? So there's 2 here and 2 here, so that would be 4. Those are our 4 vertical angles. Okay. How about number 2? I'll let you look at number 2 for a moment on your own. Give yourself a chance to challenge yourself. That's how we learn. So see if you can figure out number 2. I'll give you about 30 seconds. And remember, you can post any specific questions you have about what we're covering. If you're working on anything in summer school or another class, be happy to answer those as soon as we finish this lesson. Get you caught up on whatever class you're working on. Okay, so number 2 it is. Which of the following pair have the same measure? 1 and 7. Well, those would be exterior angles, and they're on opposite sides of the transversal. So yes, by alternate exterior angles. Bit of shorthand there. How about 2 and 3? 2 and 3 do not have the same measure. They form a straight line, so they would be supplementary. So maybe we can even say no, they are supplementary. How about C? 3 and 6. Those are same side interior angles, and those would be supplementary as well. So we could call those same side interior if you want to. So far it's just 1 and 7 have the same measure. How about 4 and 5? Oh, that's the same reason, right? 4 and 5, they are interior angles on the same side of the transversal. So it's for the same reason as what we put up here. So the only pair that have the same measure would be 1 and 7, alternate exterior angles. Excellent. So which of the following terms describes the relationship between 3 and 7? I might need to zoom out a little bit. So 3 and 7. So let me just point to those. So 3 and 7. What are those? They're on the same side of the transversal. One is inside and one is outside. The first option asks about alternate exterior angles. Alternate exterior angles would be like 1 and 7, so that's not it. Alternate interior angles, so alternate interior angles would be like 3 and 5. It's not quite what we're looking for. There's vertical angles. Vertical angles would be like 5 and 7. Those, again, would be congruent, but not what we're being asked. It's asking about 3 and 7, and the other answer choice that's correct would be corresponding angles. So we're looking at C, corresponding angles for 3 and 7. That's our answer for this one. Okay, let me pause there for a moment and let you have a look at number 4. Again, go ahead and put any questions you have in the comment box below. I'd be happy to help you out with those, covering this material or something else that you're working on. So back to this, number 4, which of the following pairs of angles are supplementary? So again, supplementary, they're not equal to each other, but together they add up to 180. So 1 and 7, maybe I'll point to them like this. 1 and 7, those are alternate exterior angles. Those are equal to each other. They have the same measure, so they're not supplementary. So A is no. How about 2 and 6? So 2 and 6, those would be corresponding angles. They have the same measure, so they'd be equal but not supplementary. Remember, supplementary means they add up to 180. So 2 and 6, no. How about 3 and 7? 3 and 7, again, those would be corresponding angles. They are equal, not supplementary. 4 and 5. All right, now we're looking at same side interior angles, and those would indeed be supplementary. Those would add up to 180 degrees. So the answer for number 4 is D. Okay, so let's have a look at number 5. Give you just a few more seconds to think about number 5 on your own, and then we will work on that one together. Okay, number 5. So the measure of angle 1 is the same as the measure of how many other labeled angles in the figure. So this is a little bit tricky because we need to apply our skill. It's not asking us which angle it's equal to. It's asking how many it's equal to. Okay, so we're looking at angle 1 equal to. So angle 1 would be equal to angle 3 by vertical angles. Angle 1 would be equal to angle 7 by alternate exterior angles. And angle 1 would be equal to 5 by corresponding angles. So how many is this? That's 1, 2, 3. So 3 of these are equal, so C would be the correct answer here. Okay. Three angles have the same measure as angle 1. Okay, I'll leave it there for one moment, everybody. If you have a question, go ahead and post it now. I can cover topics that we covered today in geometry, or if you're working on another class, be happy to help you with anything you are stuck on there as well. I'll go ahead and wrap up in a moment here. If you have any questions, go ahead and put them in the comments. You can message me. I'd be happy to get those answered for you. Okay. Let's get into title page. We'll leave it at that. We did today cover finding measures of angles formed by transversals intersecting parallel lines. Okay, that about wraps it up, everyone. Thank you very much. If you do have any questions, go ahead and put them in the comments now. I'll get them answered either while I'm wrapping up here or at the end of the broadcast. And until tomorrow, same time, same place at 6:30 Eastern Time, you can post your questions ahead of time. We'll get those answered for you, whether it's material we've covered in the course today, this week, last week, or maybe a class that you're finishing up for summer school, anything like that. Okay, thank you very much, everyone. And the link again to that brand new interface that we have set up to make it cleaner and easier for us to communicate and go over problems in the future is FloridaMathLive.com. Thank you very much, everyone, and have a great evening.